Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5, and then we have here an exponential graph. It says the graph of h of x is equals to a to the exponent of x, where a is greater than 0, and then is sketched below. So p is -1 is to +1/2 is a point on h, right? Then write down the coordinates of q. So as we can see here, q is our y-intercept, meaning that its coordinate is 0. So to look for that coordinate, you can just go to this equation here, substitute 0 where there's x, and then we know that any variable or number expressed to the exponent of 0 is just 1, right? So the coordinates for q now becomes what? 0 is to 1. So generally you should know that the coordinates here are always 0 is to 1 if your asymptote is just the x-axis, right? Then the next question, 5.2, says determine the value of a. So how do we now determine the value of a? We are given the coordinates here for p. That means we can use this equation here and substitute into that. So to solve 5.2, we have h of x is equal to a to the exponent of x. Now we know our h of x is for our y coordinate, so that's 1/2. And then we have a here, but then our x value is -1. Now we can try to express this in exponential form using the rule that says if we have 1/a, for example, this is the same as writing a to the exponent of -1. So we want to write this one as 2 to the exponent of -1 is equals to a to the exponent of -1. Now we can see that these two bases have the same exponent. So that means we have to drop the bases, right? So now we have a is equals to 2. Okay, so all that for 2 marks. Then they now say write down the equation of the inverse. So once you see this, this means the inverse of h in the form of y is equals to, so we know that they want it in the form of log, right? The inverse of an exponential graph is the log graph, right? So how do we go about this one? We can just change the h of x here to y, and then let's write it as y is equals to 2 to the exponent of x. Remember, we have just calculated above here the value of a. Now at this point, let's write let y be equals to x, because we know that's what the inverse means, right? In grade 8, when you were doing transformation and then you were given that inverse, all you had to understand was that if you were given the coordinates, let's say, for example, 5 is to 2, if they say this is reflected along the line y is equals to x, what this simply means is that your x coordinate will now be the y coordinate, then the y coordinate will now be the x coordinate. So this would change to 2 is to 5. So basically, this is the same concept you're still using here. You're saying right now, in the place of y, I can substitute x, and then in the place of x, I can substitute y, because these ones swap positions like they did here. So, okay, so that means I would have x is equal to 2 to the exponent of y. But then remember, in any equation, I should always make y the subject of the formula. Now, how do I make y the subject of the formula here? I now introduce my log rules, which you do not have to know everything about logs when it comes to grade 12. Only this log rule that says if you want to make your exponent here the subject of the formula, you just put it here and then say log base, and then you put the value there, right? So that's y is equals to log 2x. So pretty simple to memorize. You just make this one the subject of the formula, say log, and then base that, and then put your x value there. So this is the value that we are looking for. This is the equation that we are looking for, right? So, okay, now they say sketch. So we are now in 5.4. 5.4 now wants us to sketch the graph of the inverse in our answer book, right? So to sketch that, let's just erase here. Okay, so now to sketch that, I'll just sketch it here. I won't be drawing the Cartesian plane again, but then I just want to show you something here. Remember the coordinates for Q here, where 0 is to 1. So I will just use these coordinates in order to draw a correct sketch. Now we have identified that what this means in inverse is that there will be a swap of the coordinates. So the x coordinate will become y coordinate and the y coordinate will become x coordinate. If I were to swap these ones, then I understand that the inverse of Q, or the transformation of Q, will now be 1:0. So that means instead of having the y-intercept, I will now have the x-intercept over here, which let's label it Q1, Q transformation, right? So like that. So that stick there shows a transformation. I will call it a stick. Then so this one here, let's look at this coordinates. If we have this coordinate here, if we swap them, they should become +1/2 to -1, which can be somewhere here. Let's say it is somewhere here. Now note that our asymptote here is the x-axis, right? But then if we are to do the inverse, the logarithmic graph, then we know that our asymptote should now be the what? The y-axis. So that means my graph will look something like this, right? So will look something like that. So my curve is not really nice, but then I hope you get the whole point. So yes, this here being the asymptote, this here being the asymptote, and then I have my point here, and then now it's curving like that. So you should make sure that you curve it smoothly like that. And then just by using the coordinates, I was able to draw the inverse graph. So that's the method when it comes to drawing the inverses. Just make use of the coordinates that you have there, and then you'll be drawing correct graphs, right? Then now they say hence or otherwise determine the values of x for which log base 2x will be greater than 1. So basically from here, all you have to do is just for 5.6, you can choose to say log base 2 and then x greater than 1, and just try to calculate here. So we can already see that if we take the 2 here, it will lift the 1 here to be an exponent. So this becomes x greater than 2 to the exponent of 1 is just 2. So this is x greater than 2. So that means this graph here for log will be above 1 if the x coordinates start to be above 2. So that's all you needed to do. Your solution was just supposed to be x greater than 2. Then 5.7 says if g of x is equal to 100 times 3x times 3 to the exponent of x, calculate the value of x for which h of x is equal to g of x. Now we know they're speaking about the point of intersection if they give you something like this. Remember, every time they equate the graphs, we are looking for the point of intersection. So all you have to do is take the equation of h of x, which you have already identified from looking at the value of a. This is, you're going to say h of x is equal to g of x. And then remember our equation here was just 2 to the exponent of x. But then we are given that g of x is 100 and then dot 3 of x. Now you must make use of a law of exponential of exponent here that says if I have these two bases here sharing the same exponent, then I can just divide out here so that they're all in the same place like this. But then the 3 to the exponent of x will cancel with that one there. Right. But then here, these ones are dividing and then they are sharing the same exponent. You remember the rule of exponent that says if I have a to the exponent of m and then also b to the exponent of m, this can be written as a over b to the exponent of m. So they can be raised to the same exponent here since they share the same exponent. So we can just say a over b and then express them to that exponent. So this is 2 over 3. And then to the exponent of x, and then we are left with 100. Now, at this point, you can see our log rules will also come into play, right? our log rules will also come into play. Remember, log is saying if we want to make this one the subject of the formula, all we have to do is leave it here and then say log and then base here. And then we take the 1 over here, put it right there, right? So you know the one you should press from your calculator is the one with the log and the box here and the box there, right? So this is the one that will give you the correct answer. Okay, so punching that into your calculator, you have negative 11.36, right? So which should be the correct answer there? Negative 11.36. And that's how you were supposed to go about answering these questions for a total of 12 marks. Also, when it comes to exponential and logarithmic graphs, these are your free mark, guys. So make sure that you collect here. When it comes to functions on this part, just make sure you do not leave any marks to charity. So with all that being said, please press the thumbs up button if you've enjoyed the lesson. And then if you've been watching the videos and haven't subscribed, please hit that subscribe button. And if you're watching from Facebook, please like the page and follow. And then also don't forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.